So what's the value of resultant force? F resultant is equal to, I write the x and y component independently. So what's the x component of the resultant force? 3k cosine 30 positive plus 5k 3 over 5. The sum of that angle, right? So if this angle is theta, right? 5k cosine of theta is the x component, because theta is this. 5k cosine theta, right? And what's the cosine theta? 3 over 5, right? So you get that component. So x component of that, x component of that, this is pure in y, so it doesn't have x component. So that's the x component of resultant force, right? Let's go to the y component of resultant force. That's going to be 3k sine 30 negative 5k 4 over 5 negative 4k. So that's the y component of resultant force. Now what I want is the resultant moment around point O. Look, because it's in 3D, we only need one value in the k. It's either positive k or negative k. If it was 3D, we should compute 3 different resultant x and moment resultant y, moment resultant z. But in 2D, we have moment resultant z only, because moment is either in k, positive k, or negative k, right? So let's start. Let me quickly write it and then I'll explain it to you. Let's see. See? If you wanted to do this using cross product, you should have found this R1, R2, R3, and then F1, F2, F3. And then put it in the determinant, and then do 3 determinants. And then at the end of the day, it gives you this just one line that I wrote here. Right? So this method is faster. So, what happened here? The resultant moment, what was the method we used for the resultant moment? To find the resultant moment? The fast method of moving force. Look, you decompose. The first step was break it down or decompose. So let's decompose this. What is this component? 3k cosine 30. What about this component?
3k sine 30.
3k sine 30. Now go decompose this guy. That's going to be 5k, 3 over 5, thank you. And this is going to be 5k, 4 over 5. This guy is already decomposed. It's in the y direction. You see that? Now, step 2, move. So let's start with this guy. Where should I move it? This is my reference axis, right here. Here, reference point. Where should I move it? Here or here? Yeah, back, all the way up to here. You see? At this particular point, it becomes perpendicular with respect to this axis. So what's the moment arc? From here to here. Moment arc, 0.1 times the value of the component. 3k cosine 30, positive or negative?
Positive.
You take your right hand, R cross F.
It's negative.
Negative. See, I have a negative sign here. Now go to the next step. This component, where should I move it?
Down.
Down just to this point. You see, at this point it's going to be perpendicular. So what's the moment arc?
0.2.
0.2 times the value of the force component. Positive or negative?
Positive.
Positive. Right? Now let's go to this guy. Where should I move it? Down or up? All the way up to here. So what's the moment arc?
0.2.
Times the value of force, 4k. Positive or negative?
Negative.
Negative. Now we come here. This guy. Back. What's the moment arc?
0.1.
0.1. What's the value of component? 5k cubed over 5. Positive or negative?
Positive.
Positive. What about this guy? Move it up to this point, alright? Like this. Then it becomes perpendicular with respect to. So what's the moment arc?
0.5.
0.5 times the value of component. Positive or negative?
Negative.
Negative. That's it. So, if you put it in the calculator, this is just the value. That's the value, and just the value. So, you can get rid of all these things and just put a resultant force, Frx, Fry, here, and a resultant moment, just this value of this value of the computation here. And then get rid of all the force on system. You see? Simplification. It simplifies. You get a neat and clean system so you can do analysis. So you see you only have one force, one moment. That's the reason we say resultant, because it's the result of all the forces. And resultant moment, because it's the result of summing all the moment with respect to that particular point. Right? So, I think we're done for today.